Once the drive shaft has been prepared, the microtunneling equipment, which is thoroughly tested before delivery to each project, is transported to the drive shaft and assembled in position. The microtunneling equipment includes the operation cabin and remote control board, the jacking and lubrication systems, the slurry system, as well as ancillary equipment such as cranes, generators, and trucks. Then the microtunnel machine, the real workhorse of the microtunneling process, is lowered into the drive shaft and onto the guide rails. Different types of microtunnel machines are available to cope with a host of ground conditions. Machines are available in a wide range of sizes, in diameters from 12 inches to 12 feet and beyond. Once the microtunnel machine is aligned on the guide rails, which have been set to the required line and level, all cables and hoses are connected to the machine, and the total system is tested once again. The drive begins, and the microtunnel machine is thrust forward by the hydraulic jacks, first passing through the entrance ring, then tunneling through the ground on its journey to the reception shaft. Powered by electric motors, the rotating cutter head cuts through the earth. Excavated material is crushed in the head of the machine when necessary and passes into a slurry chamber, where it is mixed with slurry and transported to the surface via slurry pipes. During excavation, a sophisticated earth pressure counterbalancing system is employed. By maintaining a consistent counterbalance pressure on the tunnel face, always between the active and passive earth pressures, ground movements are virtually eliminated. After the machine has fully penetrated the ground, excavation is halted, cables and hoses are disconnected, and the first section of pipe is lowered onto the rails. The pipe is pushed up to the back of the microtunnel machine, where they are joined by an adapter ring, and all systems are reconnected. Then, together, they are jacked forward as the excavation at the face of the machine continues. On the completion of the jacking of one pipe, excavation is stopped. The jacks are retracted. Another pipe section is inserted behind it, then pushed forward, and the process is repeated until all the pipes are installed, forming the permanent tunnel lining. The alignment of the machine and pipe is controlled using a laser-guided steering system. A laser beam originating from a laser at the rear of the drive shaft and set to the required line and grade is projected onto a target mounted inside the microtunnel machine. An image of the target is captured by a TV camera and relayed to a monitor in the remote control board at the surface. The operator can activate hydraulic steering jacks inside the microtunnel machine as necessary to articulate the front section of the cutter head and alter the attitude of the microtunnel machine. Accuracies of plus or minus 1 inch in line and grade are typically achieved over an entire drive.